Good day, everyone. Welcome to Direct Stars. Our subject for today is physics, while our topic is particle model of matter. Subtopic is states of matter. I know we all understand what matter is. Matter is anything that has weight and occupies space. So, aim of today's lesson is for you to understand all the states of matter. Objective of today's lesson, at the end of the lesson, you should be able to know the different properties of solids, liquids, and gases, the arrangement of particles in a solid, a liquid, and a gas. So let's move to state of matter. Firstly, we need to understand what is the particle model. Yes, particle model. What does it mean? You know, all matter is made up of very small particles, and that small particles, well, another name of it, we can call it atoms. Okay, so this particle model is the model that describes the arrangement and movement of particles in a substance. That is, the arrangement and movement of this particle in a substance. The particle model can be explained is that different state of matter, which is solid, liquid, and gas, or the physical properties. And what are the physical properties? Like the volume or the density of matters. So now let's go to solid, liquid, and gases. You know, everything around us is made up of matter. Yes. It exists in one of these three states. Is it either solid, liquid, or gas? So, have you ever wondered how it is possible to put your hand through a liquid, even through the air, which is gas, but not through a solid particles, just like a door, right? Now, because of the particle that is made up of this matter, that is why you can't put your hand through a solid particles. So, what are the particles made up of this matter? That's where we come and we get what we call the kinetic theory of matter. What is kinetic? Kinetic means movement, remember? So, theory of matter. So, the kinetic theory of matter explains the behavior of matter based on the idea that is matter are made up of tiny particles, atoms, or molecules. They are in constant motion. What are these constant motion? Or what do we call this constant motion? Then that's where we have Sir Brownian. Then we call it Brownian motion. Brownian motion. Okay, so let's go to solid. How does solid look like? What are the properties of solid? Now this is solid. Yeah, solid. Now this here is what we call volume. You can see this rectangle here is what we call volume. That is volume. Why? This is the tiny particles in the volume. Okay? This is the tiny particles in the volume. So, in solid, okay, I don't want to take much time. So, in solid, we have these particles they are closely packed and well arranged. Closely packed and well arranged. Closely packed and well arranged. Okay? So in solid, they are closely packed and well arranged. Particles in solid, closely packed and well arranged. So I want to show you how they are closely packed and how they are well arranged. Closely packed, that means there is no distance between those particles. Okay? All those particles, they touch each other, one another. So now let's go with this. Solid. In a solid, the atoms or the molecules there are packed in a regular structure. You can see a regular structure. We have this, we have this, we have this, we have this, and this. Regular structure as the role and the color. Okay, so the atoms cannot move. Though, yes, it cannot move because they are in a fixed position. Yeah, but they can vibrate. You know, there's difference between move and vibrate. Even the vibration is also known as movement, a little, okay? Because when something vibrates, at least it moves in a little distance is covered, right? So the atoms cannot move, like freely they cannot move because they're in a fixed position, but they can vibrate. So solid is the only matter that has the ability to vibrate. So the atoms are held together strongly with what we call a strong force, intermolecular force. So it is difficult to change the shape of a solid. Why? Because the particles there are well arranged, well structured, and they are in a fixed point. So it is difficult to change the shape of a solid, only when you use external force. And that external force is that you want to break some particles out of this solid. That is when you change the shape of a solid. So this is solid. Solid has a fixed shape and volume. This is what we call solid. It has a fixed shape and volume. Now let's go to liquid. 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 The atoms in liquid is just so funny. Yes, they are closely packed too. Closely packed. Why do we call it closely packed? Closely packed means they add together too, truly. Yes. But they are not in a fixed position. We can see the difference now. They are not in a fixed position. Yes. Do you know that? Because they are not in fixed position, that is why they can flow. So when liquid flow, all these particles, they flow together because they are closely packed. All these particles flows together. That is why liquid has the ability to flow. Remember, solid has the ability to vibrate, while liquid has the ability to flow. Here, we don't really have what we call roll and column. No. What we have here is they are closely packed, and the closely packed of it is why they can flow. Fine. So, closely packed. The force between atoms keep them in contact, but atoms can move from one place to another. Yes, that's why they have little space here. So if this is moving, then the other parts of this particle are moving with it. That is why we have liquid. And this liquid can flow and change shape. Why did they change shape? They can only change shape to fit the container, to fit any container they are into. Liquid fits their own container. It doesn't have an actual or a fixed shape. Because the atoms are close together, it is very difficult to compress a liquid. Very difficult to compress a liquid. So examples, we have water, we have oil, we have cheese, milk, and honey. All these are examples of a liquid. You can see the particles here. Now, a liquid has fixed volume. This is what we call volume. Okay, that is volume. But we flow to take the shape of a container. This is the container. You can see this is cylindrical shape, and it takes the shape of its own container. That is liquid. Now we go with gas. Gas. Gas sounds funny. Why? Because in gas, the atoms there are separated by relatively large distance. Large distance. Large distance, 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 distance. Why? Because the force between the atoms are very small. The force between them are very small. So the particles are not in contact with one another. So the atoms in a gas are in a constant random motion. When we say random motion, random means no specific motion. So a gas can expand to fill any volume. Examples of gas, we have oxygen, we have nitrogen, propane, natural gas used for heating and cooling. We have carbon dioxide, we have carbon monoxide, oxygen. All these are gas. Air, gas. You can see these are the particles there. So a gas will expand to completely fill a container. So a gas can fill its own container. I mean, just with little particles, they can fill up their container. How would they fill it up? This is it. Let me just say this is a container. So when one gas is here, the other is here, the other is here, while the other is here, and they are just moving randomly, then they'll fill up this container. That is how gas fills up its own container. So all these are the properties of matter: solid, liquid, and gas. And you can see how their particles behave in the volume of matter. So that'll be the end of today's class. I hope you understand what states of matter is and what matter is itself.